everyone. Welcome to another episode of the Data Standard Audio Experience. I'm your host, Catherine Tao. Today we have Ben Ogorek, the former CTO and head of data science at Newsot. And today we're going to be speaking about preventing errors and mistakes in predictive modeling. So welcome to the show, Ben. I'm excited to hear more about your journey and some of your past experiences with predictive modeling.
Yeah, thanks for having me, Catherine.
Go ahead and introduce yourself. Tell us more about your experiences.
Right now, I am working as a freelance data scientist, servicing a contract that my former employer has with Facebook. So what that means is I am building a forecasting platform on top of Profit that data scientists will use to do some of their metric forecasts. And it's one of the reasons that I'm particularly interested in reducing mistakes and building a system that is of the highest quality possible. It's always, a gift if you're building something that people are using, but it introduces a level of responsibility. And based on some of the experiences that I'm going to tell you today about, I know that a mistake at the wrong time in the wrong place can be really detrimental to your efforts. So, just a real quick highlight of my previous experience. I got my PhD in statistics at NC State back in 2008 and, entered industry at Nationwide Insurance. It was a great place to be because I got to meet IT professionals in a Fortune 500 company, worked on a project that we called the Model Factory that was about developing protocols, practices, standing up technologies for building and releasing predictive models so the business could release them efficiently. So that project has, led to patents and things like that, which it's been, a pleasure to have been a part of. So during the time at Nationwide, the big data movement revolution started. I'll never forget the McKinsey paper. And, I could feel the stock starting to rise, right? I got an email from a recruiter at Google that led to a position in HR analytics at Google, where I was there for a little over 2 years. After that, I led a team of predictive modelers at a Midwest insurance company called CUNA Mutual Group. I was a director of predictive modeling there for 3 years. And after CUNA Mutual Group, I tried out freelancing, started working for Newsot as a freelancer, spent some time as a CTO at Newsot, and now I'm back to freelancing for them. So that leads me to where I am today.
Yeah, that's awesome. And it sounds like you have a lot of different experiences to kind of pull from to get to where you are today. So that's awesome. Thanks for sharing.
Sure, yeah, I've seen a lot.
Yeah. And so I kind of wanted to just jump into the overall topic of today's discussion. And we're talking more about predictive modeling and how to mitigate any challenges that people are facing. So for you, since you've had a lot of different experiences, what are some of the common mistakes that you've seen happen in predictive modeling?
Sure. So I'll cover the easy one first. We've all, seen it, heard about it. Overfitting occurs a lot. Sometimes it's obvious, sometimes it's less obvious and more hidden. Another one that occurs probably as frequently and is sometimes harder to detect. The world changes and you assumed it wouldn't. If you're a time series person, it's like you assumed a stationary system, but actually there's non-stationarity and things just break down over time. Sometimes in cross-sectional data sets, you'll see the future creep into the past. Somebody pulls, a column that in reality, would not be available to you at the time of scoring, but it's in your data set and you model with it. Off by one errors, you're lagging something, it shouldn't be lagged in production, but it's lagged there. Other types of like mechanically added error. So, the kind of a worst case situation would be if, say, scores get flipped upside down and you can't tell the difference, right? You model the probability of 0 instead of the probability of 1, and it goes out the door. Another type of mechanically added error that I've seen a lot is kind of like a naive deduplication. So someone, notices they have multiple records, and they just dedupe. They just toss them, take an arbitrary one, and they, miss out on important information. And then finally, two more. So complexity getting out of control. That's something that I've seen cause a lot of trouble. At least it's a fertile ground for errors. And then finally, thinking that you understand the system that's generating your data and being overconfident about that. So I guess that's, pretty good list to get started.
Yeah, definitely. You listed out a lot of the important problems, definitely, that a lot of people are facing. I think it's great that you brought them up because a lot of companies are facing the same problems, but I feel like people aren't talking enough about the challenges that they're facing. And so do you have any specific stories that you can share that with just issues or problems that you've seen that you've encountered with predictive modeling?
Yeah. And Catherine, your point about, companies and people not talking about it. I think like that is the problem, is that there's like a natural tendency to not talk about these things because they're embarrassing. But so I'm going to tell you a few stories, including the very beginning, right? Me getting started in statistics. I'm in a Stat 101 class. I'm 18 years old, 1999. And there was a speaker. His name was Bruce Weir. And he was a very distinguished, or is a very distinguished biostatistician, statistical geneticist. And he talked about his experience testifying at the O.J. Simpson trial. And during his cross-examination, there was a mistake that was pointed out in his analysis by a statistician on the defense. And it turns out he had left out a marker, some genetic marker that actually biased his analysis slightly towards, making the samples that were analyzed look more rare than they were. And just recently, I think about that, right? I think about that story. At the time, I didn't really know what to take away from it. Like, well, people make mistakes, and this is an interesting story. But I went back and I read, some of the original like LA Times articles, and you read about what happened in court, right? Where he admits it was a mistake, it was an error, and two jurors, like their eyebrows go up, they look at each other, and like everybody with a notepad starts writing furiously, and it's just like this point that the defense is constantly they're using, right, to discredit. So that was kind of the first time where I realized that you could make a mistake in statistics and modeling, and it could potentially have consequences. But I didn't really know like what to make of it. So the first time I saw a mistake in industry was during my time at Nationwide, and there was one clear case of overfitting, where they look like there was a lot of value on the table that could be captured if you were to slice and dice the world in this way. And there were roadshows with the number that could be taken off the table, right? And the model ended up, in the words of the analyst, collapsing, right? So that was one real world instance. I'll talk about my first error, which was also at Nationwide. I had lagged predictive variables. That was fine for the past, right? Because it was the lagged version with the current version of the response. But then when it was time to put it in production, well, I did that myself, and I left the lags in. So it was going back 1 month in the past. So it was old, right, data. At Google, I saw, so Google had a great culture in terms of talking about mistakes. They actually would reward that behavior if you went up and talked to the team about mistakes and errors. There was one, just a powerhouse, cognitive just powerhouse that developed probably the most complex forecasting model I've ever seen. And it was, based on Monte Carlo simulations and all kinds of stuff. And it was so complicated that, only he could really do it, right? He could debug it, work on it, and he had the energy to do it. There was a point at which he couldn't fix something that broke. The model just didn't get run for weeks and weeks on end. And eventually it turned out to be like a bug in data table, the R package data table. But that was an instance where like you could argue about whether or not it was a mistake to incur that type of complexity, but it definitely led to a situation where the analyst was stressed out. There were weren't model scores when there needed to be model scores. And then finally, I'll talk about the mistake that makes me think about mistakes and will make me think about mistakes for every day of my life. My time leading a team at CUNA Mutual Group led to an experience where I had a great team of data scientists, more on the junior side in terms of experience. We were running hot in terms of, pushing new techniques out the door, releasing new features. And I knew it, but I didn't want to, get in the way of the momentum. And we put a model in production that was inferior to its predecessor. And when we communicated what happened, we got super unlucky in that there was something else that was 10 times bigger that nobody even knew about at the time. So we got frozen. The rest of my time there was a quest to thaw the team. We actually had a project called Project Spring, but people were so spooked from the mistake, that like when I was reading this experience of the biostatistician Bruce Weir in court, it's like, wow, like that sounds familiar. And the team, they finally got thawed. They're releasing models, but that was something where I realized that I need to start taking risk more seriously as a leader, and then as even as a practitioner, in diagnosing exactly what happened in that mistake. It's really hard to do the forensics on that. My best understanding is that there was an overfitting in one of the components of the model that led to more variability than we would typically see in that component. And then that component ended up being the primary driver of the scores. And when things were ranked, right, it led to unfavorable outcomes relative to the predecessor. I'll talk about some of the things that I learned from that and the way that the team actually improved. But I guess I'll leave it there. That's a full scope from the first time I realized that you could make a mistake that could hurt in 1999 to making my own mistake that hurt in 2018, and where I am now in terms of trying to build systems with the lowest risk possible.
Yeah, and isn't that crazy that court case that you brought up, that one mistake that he made, everybody just viewed it as he's not credible anymore. And that's crazy to think about. That one mistake that you make could happen like that. But it's also, mistakes in industry are common. They happen all the time. And like you had shared your experiences at Nationwide, and they're common things. And I think it's also great that you also brought up, I believe it was Google that you mentioned, that rewards people for mentioning the flaws that they see within certain predictive modelings or any math that they're doing. I think that's super important. And I think that's something that more companies should be adopting, just so people aren't afraid to be able to speak up. And it's better in the long run too, if someone can catch those problems that you're seeing. You can save time, money, and resources for the company. So definitely great insight there. Absolutely. And you've mentioned a lot about different challenges. And so I wanted to hear more about how companies and teams can really mitigate these risks and problems that you've seen.
Sure. I'll start off with a little bit of the epilogue of the last story. Before the mistake, I knew the team was running hot. There was a coworker named Katya Hall that approached me. She said, I'm running a new discipline called model risk management. And I want to, interview your team members. I want to learn about what you do. And I blew her off, right? I hid from her because we were too busy. And after we were frozen, I came back and I said, Katya, I need your help, right? I'm ready to sit down with you and talk about what you do in model risk management. And it's a shame that it took, something bad happening to get serious about managing risk. When you look at the history of, say, the EPA, right, or TSA, or any organization that is responsible for stopping bad things before they happen, chances are they were started by a bad thing that happened. And there's another team at CUNA Mutual that had a model risk management discipline, and I asked them, how did this thing get started? Guess how it got started? Some model blew up, right? And all of a sudden there's a model risk management discipline. So I worked with Katya extensively for the next year and a half. And so here are the things that she taught me about model risk management, which I think it's linked, it's connected to MLOps, which is a lot buzzier, right, than MRM. So the first thing is get a model inventory. Sounds really simple. And at first I'm like, I don't need a model inventory. We have GitHub repos. Just look in the repo, you can see the models. Well, how many models are in that one folder? Well, it depends on how you count. Maybe 52 if you count by state, or maybe. Yeah, well, step one, right? Define what a model is, right? Put it down. It doesn't have to be anything fancy. It could be a document. It could be a spreadsheet. But decide what makes a model. Write it down, and then you can talk about it. You can talk about how much risk there is if something goes wrong in that model. You can talk about where things could go wrong. What are the likelihood that things could go wrong with that model, right? So the inventory, it seems so simple and basic, but it's deceptively simple. And it gives you a great foundation discussing things that could happen that you don't want to happen. The second thing is creating some bureaucracy, which again is a dirty word when you think about moving fast, but the bureaucracy is helpful bureaucracy in the form of process checklists. So basically, we got to the point where whenever we build a model, released a model, tested a model, monitored a model, we would bring a card from a Trello board, again, low tech, onto whatever sprint we were on, and we'd follow it through. And so checklists are another thing that sound like they're, kindergarten, but they're really not. And I did some research on the history of checklists in two different fields, aviation and medicine. You can find some NPR articles on this where brilliant, talented pilots, they're dying, at the turn of the century, 1920s, 1930s, because they're forgetting to do something. And of course, these pilots, they had this list, but eventually, enough people died that now, like, aviation is like, it's a place where checklists are heavily used. Same thing in medicine, in terms of operating on the wrong thing or something like that. Stuff happened all the time, and they use checklists. So checklists became a key tool. And having a checklist means that you have a process that you apply every single time. The one thing that I would do above all else, from a statistical perspective, is to take every single input into the model and run a quality control chart, like a individuals or a Schuhart chart. The QCC package in R is great, and have charts for every single input through time. And that's something that took our team from a team that caused problems to a team that preemptively found issues. The average of this input dropped to half of what it was before. And then all of a sudden there's a problem in the database. Like, oh, well, those, these things turn into zeros. And so that's just like, monitoring is like step one. If you don't have a system that's just monitoring all the inputs over time, you're setting yourself up for a lot of risk. We did run a suite of tests. We had sanity tests that were, coded up in unit tests. Again, like, models are complicated, right? But if I know that a certain age range is more likely to say, respond to a marketing offer, hey, take all the ages and put them at that range, and the score better go up, right? Just like basic sanity checks. We would do integrity checks. So, moving from a local environment to a production environment. We had a process for storing the input data and the output data, like a sample, so that you could reproduce that in the final pipeline. And we did have a process where we had a role called a test data scientist. And the test data scientist was responsible for just making sure that whatever was done could be reproduced from the actual raw data. And finally, Katya did have team members. So there was model risk management data scientists, right? And they would help us on the team, which, again, it's a luxury, but it was really helpful.
Yeah, no, that's awesome. Thank you so much for just sharing more about your experiences and mitigating these risks and problems that you've encountered, especially with predictive modeling. There's so many things that can go wrong and so many common issues that people are having, but just not speaking about. So thank you so much for sharing your experiences there. Where can everybody find you online to connect with you?
Sure. All my handles are just my name, Ben Ogorek, Benogorek. So I do write articles on Medium, kind of infrequently. Write mostly about statistics on Twitter. I post things about statistics, and that's also at Ben Ogorek. LinkedIn, I believe, is also just Ben Ogorek. Connect with people who give a personalized message that's not marketing related. But I basically follow back everybody on Medium and Twitter. Yeah, and I guess those are the three.
And to our audience, for more information on the data standard, you can find us at www.datastandard.io, as well as our YouTube and LinkedIn page. And this episode is sponsored by Pandio. They're innovating this tech space with their Apache Pulsar messaging system. So you can learn more about their work at pandio.com. And thank you, Ben, for joining us. So great to speak with you, and such a pleasure to have you.
Yeah, Catherine, this has been a lot of fun. Thanks for having me.